Alright, so this is the video where I'll actually slow down and explain the answers after you've done them. This for block F will replace what we were going to do in the Moodle day where we had 20 minutes to get you started on this and we lost it due to the internet problems. And then I was going to get you to continue on, so I'll do it all here. 16's a woozy. But it's not that, it makes sense. It's just that it would take your full 3 minutes. So I'm going to take the full 3 minutes to explain it and the answer after you have tried to do it yourself. So that's the way you should approach this. Listen to my introduction to the question, my hint or two, then I'll stop. You pause the YouTube video, do it on your own, either in the textbook or on paper, and then come back and listen to my explanation. So this is my setup, first of all. The following code fragment is intended to find the smallest value in an array. Everything here is kind of regular. The min starts at where we would expect it to. I goes to 1, which might make you wonder a little bit, but that's okay because we've already looked at, we've already assumed 0 to be the min. And so then we're going to look at, in turn, 1 and above. And so while I is less than n, that makes sense. I++, I don't want to give it away, but basically this is supposed to be looping through the array, and if each individual element that we're looking at is less than the last min that we've recorded, then the min is that new element. So take a full 3 minutes, if not even a little bit more for this one, to look thoroughly through it. And in case you don't have the textbook with you, I'll just show you those are the options down here at the bottom. I can't fit it all on the screen. 1, 2, 3 only. 1 and 2, 1, 2, and 3. So take your 3 minutes and pause the video. Try it now. So the explanation, I'm not so sure that tracing over here will be necessary. I think I can just explain it by pointing through. So yeah, here was the issue. I++, before you get into looking at the element of the array, well, it's going to cause a couple of problems. Number one, we will never have looked at element number 1. It's fair enough to start the I at 1 because again we've looked at the 0 and we assume it to be the min, but immediately before even looking at the array index 1 we bump it up to 2, so we never look at 1. Furthermore, you're going to have another problem here because whenever in any of these questions you see an I++ before using that I in an array, in all likelihood you're going to be accessing 1 past the end of the array. If we're less than the length of the array, that's fine. If I goes up by 1, then we're the length of the array. If the array is 5, it does not have an element 5. And so we're trying to access that element 5 and we're going to get an error. So 2 problems there. So number 1, does this change things? We change I to 1 instead of to 0. Well, it changes or helps the one thing that we'll actually be looking at index number 1. Because the first time through, if I starts at 0, we'll be looking at 1. So we will have looked at 0, and then we will look at 1, and that's fine. But we still have this I++ before accessing element I. And so we're going to have that problem where I is going to go up to n, and then we're going to try to access the array n, which is the length, which there is no element that is that index. So an error. So solves one of the problems, doesn't solve the other. Next, this looks more comfortable. That this while loop changes into the traditional, do something with the I, and then bump it up so you can continue your while. And that works, right? If the element is less than the min becomes that element, and we keep on going through, the I++ happens at the end. When you do a while loop, the I++ is at the end. Right? And that is at the end of the while loop, and so it's going to work. It's going to work. Number 3, change the test to be while I is less than or equal to n. Well, that's just making it worse. That if there was anything you could do to make it worse, that's about the only thing I can think of. So no, you still have the same problems. You miss looking at the 1, and it's going to go. Well, it's never going to get to equal to the n because it's going to equal n because it's worse. So the answer will be 2 only, which is B. All right, so, it is funny. When I look at this now, having looked at it before in class, it seems a little bit easier to explain. But for this to just jump out at you in the middle of an AP Computer Science exam, you can imagine, out of the blue, to try to get it all figured out in your head, it's kind of tough. That's why I say this is a woozy. But for what it's worth, and there are going to be much better questions for you to be doing and looking at when you do this, but here it is. Fast forward through this if you don't want to bother, but I'll give you the explanation. The idea is that you've got a couple of arrays, V and W. All right, and N is the number of elements in this one, and M is the number of elements in that one. And the idea is that you're looking for whether or not they have common elements or values, and they do. 78 is common to each of them. So assuming that this method above, the match method, has not been exited, which assertion is true at the end of every execution of the while loop? So there's the while loop. The while loop's going to go through, and it's going to be checking basically to see if two of these indices are equal. And if they are, it's going to return true. A is the answer. And let's just look at A only. It's just a whole lot of V's and M's and indexes and W's and everything else. But A is correct. That what's happening here, basically, is as long as, and I should have made these different sizes. Let me just go make this a different size just for, but the one thing that I didn't mention is that they do have to be in ascending order. They have to be sorted. So basically the way the while loop is going to work is that as long as we haven't reached the end, so I'm just going to have this go traverse down through via the plus plus here, and this is going to traverse through one step at a time via the plus there. Basically, if we get to a point where the two are going to be equal, then, and eventually we will, I don't know exactly how these go, but sooner or later it's going to be something like this. And they're the same, and so we return it. And this else, if and else, is going to determine which one of the two pointers, as it were, moves along. So basically, in the middle of this, before we find that the two elements we're looking at are not the same, then at the end of every while loop, we haven't found them equal at the true. So we've done this, we've done that, and we're coming back up. So what's true? Well, at the end of every while loop, we haven't reached the end, that's for sure, because the while loop says that we got to go up until we reach the end, and we haven't returned anything. So we know that up to the point where we're at, there are no common elements. Crazy question, I think, but that's it. So when we move. Okay, this looks more manageable. So this is one, even before reading through it, that I'm pretty sure you can take your 2 minutes and do and try to come up with a good answer. Let me explain what we got here first. So we got a book class, Boolean checkout status. Okay. All right, and we just have this one method here, one mutator, which is change status, which makes whatever the status is to be the opposite. So if the status was false, it becomes true. If it was true, it becomes false. Client program has a declaration of book list. Suppose book list is initialized so that each book in the list has a title, an author, and a checkout status. The following piece of code is written whose intent is to change the checkout status of each book in the book list. Okay, geez, something tells me we might have done this one too, but I'm going to do this as if we haven't done it in class. So look at this. I'm not going to give you a hint, or am I? The hint is that there's certain things that you can do within a for each, and there's certain things that you cannot do. One of the things you cannot do, or basically all the things you cannot do, is insert or delete or make new elements. But without giving it away too much, so pause it right now if you don't want me to give it away too much. Without giving it away too much, you are able to call mutator and other methods of objects. So go ahead and try it. And that was the point. The point was, that it's okay. You can do this. There's no new here. You're not deleting or inserting or adding new objects here. You're just changing the status via a mutator, and that's okay. You can use a for each to do that. So it's going to work. We're going to go through the book list. There's our B. Change status is a method in each of the elements, which is a book in this book array. You can do it. So the answer would be B, that each book in the book list array will have its checkout status changed as intended. It works. It's fine. So for 19 and 20, we have the bingo card class. It has an int array of cards. If you know how to play bingo, you're just stamping different numbers if you've got them and you're trying to get a row. So constructor, fair enough. It's going to create a bingo card with 20 random digits. And then display. I'm not sure what we're going to do with that. So a program that simulates the bingo game declares an array of bingo card. The array has a num-player element with each element, where each element represents the card of a different player. Here is the code segment that creates all the bingo cards in the game. We declare an array of bingo card, and we construct each bingo card. So number 19 just says, which of the following is a correct replacement for declare an array of bingo cards? So this is a straightforward question. This is probably really easy. So there's your bingo card. It's a class, and we're declaring an array of it. So go ahead. What's the answer? So it's going to be a bingo card array. Assign new bingo card num players. Bingo card array players is a new bingo card. We probably want to put num players in. So rather than 20, let's put in the num players. There it is. Bingo card array, whatever, is assigned new bingo card D. And then we move to the correct replacement for constructing each bingo card. Well, immediately, based on what I said up about this, what was okay to do in a for each and what's not okay to do in for each, that's what this question is about. So you can pause it now and think it through. And so I'm back, and yeah, you cannot, with a for each loop, make new or delete or insert into an array anything, ints or bingo cards or whatever. So wherever you see new inside of a for each, it's a no-no. So that's a no-no, that's a no-no, that's just awful. That's fine. So we're going to loop through our array of players, which are bingo cards, and for each one of them, a new bingo card. 3, which is C. So these are definitely much more straightforward than the first couple that this video started with. And I guess this whole end of chapter multiple choice goes that way. There are 40 questions. Beginning of the next kind of section, and then really hard question. Beginning of the next section, and really hard one. So number 20. Straightforward. I think just do it, and I'll give you the answer after you've unpaused. So this then is the beginning of the questions on array list and list. You'll recall that list is an interface. And so that's fine. You can go list whatever of strings is a new array list. That's okay. Strings. List int. This is wrong. You cannot make a list or an array list of primitives. You can only make lists, array list, linked list, and so on, of objects, reference types, and this is not a reference type, so that's not true. How about this array list? And then this is fine. This is just saying that the actual is given the real type, and that's fine. So 1 and 3 are both correct. D. 22. This also should be fairly straightforward. Just keep in mind, pause it right now if you don't want the hint, just keep in mind, same thing, that lists, array lists, are lists of objects. And they must be, I suppose the other hint here is they must contain the same type of which they were made. So string in this case. So which statement will cause an error? Well, this array list is an array list of strings, so as long as it's got strings, it's fine. So we got the string ch and an integer, probably going to be a problem. Blah, blah, blah. So we add a ch. Ch is a string, that's fine. We try to add a new string out of the string literal, that's fine. We try to add the int obj, but we convert it to a string, so that's also okay, because we end up with a string. Here we go ch plus 8. That's going to be a string plus an int. String plus an int. String is the bigger type, so the casting is toward the string. So this actually ends up being a string. So it's okay. Which leaves us e, which must be the one that causes the error, because int obj is an integer plus an int. This is the bigger type, so the casting is an int to an integer reference type. And you can't add an integer to an array list of strings. E. Number 23. Number 23 is, it's about get and add and remove and set, making sure you understand how they work. A couple of them are straightforward to understand, a couple of them are not. So, and immediately when I see 6 here and I look at the number of elements up here, I'm immediately I'm drawn to wanting to count 0. 1, 2, 3, 4, 5. Yep, lo and behold, there is no 6, so that's probably going to come in to importance here fairly soon. So get is going to return. It's going to return the value at 6. Oh, and the question says, which of the following statements would not cause an error? So they all cause an error except for one. So yeah, that's an error. It's an error because there is no 6. We can add, well, that's not a 3,4, that's a 3.4. I'm not sure if you can see it on your YouTube video or not, but that's a double. You cannot add a double. There's no casting going on here. You cannot add a double to an integer array list. Sorry, you can't do it. That's also an error. Now this is the curious one of them all. Can you might not know this, so just consider this. Do you think you can add at number 6 the value 9? There is presently no number 6, but number 6 is one pass. So even if you're not sure of that, you can look it up in the book, I think, but I'll explain here shortly. Let's look at the other two. Remove 6. We definitely can't remove 6. And this is where, by the way, it says, assume that each statement applies to the given list independent of the other statements. If we had added the 6 successfully, then we could have removed it, but we're just supposed to look at this independently, this whole line, and you can't remove something that's not there, so that's an error. And the same thing here, you can't set, which removes and changes the value. We'll look at set again, but set's the tough one. Just for now, that's an index. It's an index which has nothing. So error, 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 error. Yes, you can. You can. And you can. You can add to the tail end of a list, so that will add 9 to index 6. All right, number 24. Number 24 is one of the harder ones, but it's explainable and understandable, and I think if you took your 3 minutes, you could probably get it. And just by doing what I'm going to suggest for you to do, try it and see what you come up with for the answer, and then I'll explain it. So let me set it up for you first. So the idea is that we have an array list of string objects, and the list contains string values sorted in decreasing order. Walter, Susie, Dan. This is if anybody from Block D is looking at this. When we did this in class, that was the mistake I made when I wasn't convinced of the answer, because I was thinking that the names were in ascending order. They're not in ascending order, they're in descending order. So anyway, they're in descending order. And what we're trying to do is insert in the proper place, alphabetically, a new name, which array lists can easily do. So we got this element we're trying to insert into the list. The index starts at 0. And so let's take one that's going to be normal, because what you end up with, and I'll just preface or preview this, is that basically you're going to say that it always works, it never works, or it works except if the name to be inserted is greater than the first, or if the name is less than the last. So I'm taking the normal situation first, just to show you how it works. So there's Peter. We're going to say while the element, Peter, compared to list get index 0, which is Walter, is less than 0. Is Peter less than Walter? Yes. So index goes up by 1. Index goes to 1. So now we're going to compare Peter to what's at index 1, which is Susie. And, PQRS, yeah. So he is less. But then, when we compare him to Dan, he's not, and so the index would have been left at 0, 1, 2, and Peter does go at 0, 1, 2. And Dan will be shifted over, because that's what array lists can do. So it works for the normal case. How about for the case where the name is greater than the first, so we don't even get into the while loop, right? So that's never true. The index never goes up. The index remains at 0. We add at index 0, Zoe, yeah, that's fine. So Zoe gets added there. Walter, Susie, and Dan all have their indexes raised by 1. The size of the array list changes, however that's possible to do in memory, but it works, because that's what array lists do. And then we checked if this one, if the element that we're trying to insert is smaller than the last element in the list, and so is it less? Yes. Is it less? Yes. Is it less? Yes. Index goes up by 1. And we don't yet go down to here, and that would actually work. We saw that in the former question. You can actually add onto the end of the list. The index can be the length of the array list, but that's not the problem. What's going to happen here is that because Abigail is less than Dan, index goes up by 1, and we do the while loop. We check that condition one more time. We try to check to see if list.getIndex. Well, not yet. There is no element there. So that will be an error. We never make it to here to add on Abigail. So the answer is D. It works normally, but it fails if element is smaller than the last item in the list. Tough one. Hopefully you got it, or you made a good stab at it anyway. Next, 25. Oh, jeez. Another woozy. All right, I've got it all set up for you. 618. Length is 3. I stars at 0. First of all, list.add. So this is the index, that's what we're adding. I plus 1 is going to be 1. So at 1, we're adding 0. So at 1, we're adding 0. Which means that these two shift over, 9 and 8. When you add, everything else shifts over to the right, and the rest remains the same. Then x is going to gobble up set. X is there just to receive what set returns. So set, this is the index, I is still 0. So at 0, we're going to set I plus 2, 0 plus 2 is 2. So at 0, we're going to put 2. At 0, we're going to put 2. Now, set does not disturb the rest. It does not shift over. We're not adding. We're simply setting one of the elements to be something else. So we come down here. We go back up. I becomes 1. Okay. And 1 is less than the length. So we add at element I plus 1. So we add at element 2. We add 1. At element 2, we add 1. And the 1 and the 8 shift over. Okay, and so next, set I is 1. At 1, we change it to be 3. This changes to 3. Everything else remains the same. Okay, I goes up by 1. 2 is still less than the length. So I is now 2. So we add I plus 1. At 3, we add 2. At 3, we add 2. Everything else shifts over. The 1 and the 8 shift over. And this remains the same. And our last line, set. So we're just going to set the second element to be 4. Second element to be 4, not disturbing anything else. So 2, 1, 8. A 2 and a 3. And fortunately for you, you don't have to use Photoshop on your exam. 2, 3, 4, 2, 1, 8. A is the answer. Yuck. 26. 26, 27. Coin and purse. So we're probably going to have an array of coins in the purse. Here's the coin, straightforward template class. Value and name. For example, 25 cents would be a quarter in America. Constructor, get. And then this is kind of weird that you can take in an object to see if an object equals the coin's name. I don't know why they did it this way. This is just weird. But basically, if one of the names equals the name. So if you send another coin, which is an object, so you can do it to this parameter, then the name here, if it equals the object sent's name cast to a coin. Why they did it that way, I don't know. If the names are equal, you return true. And your purse, there you go, has a list, not an array, it has a list of coins. Okay. You don't have to give a size, of course, for an array list because it's a list. It keeps on growing and shrinking as at will. And we add a coin, add coins.add coin. Right, because it's just an array list, so we just add a coin, easy. Get total. Probably going to be doing a question about that, looping through the list of coins. So, coin and a purse, which is an array list of coins. Okay, got it. 26. I think this is just another one of those fortunate, are we using the for each correctly? Because all you're going to do to get the total is total up all of the get values, right? Whatever it was. Yeah, get values of the coins in the array list. So we're looking for a C and a C. We don't need to do that. We just need basically C dot this. Don't look at all the rest of that mumbo jumbo. Basically, that's it, right? Because the total is going to be plus equal to, oh no, where's the C? C, this one then, E. Get value. There's your C, there's your C, and you need to use the get value. E is the answer. $27. 2 coins are said to match each other if they have the same name or the same value. Okay, same name or the same value. So a Canadian quarter could equal a American quarter. Okay. You may assume the coins with the same name have the same value. Coins with the same value have the same name. Okay, so forget the Canadian US thing. A Boolean method find is added to the purse class. Takes in a coin and it finds a match. Right, so we're returning true if the purse has any coin that matches the coin we're sending. Do you have a quarter in your purse? We go through, and if we ever find an equal value, then we return true, otherwise we return false. Give you a moment to come up with the answer. And the answer is 1 and 2, but not 3. And I'll just jump right into the get value. Get value returns an int. And this is a tricky one you might have missed. Get name returns something that equals works with. Get name returns a name, and a name is a string, and a string is an object, and an object has equals. Well, string has equals. So you can do that. And you can also do that because that's what I hummed and hawed about up there when I was describing it. It has an equals method. It takes in a coin, which is an object, checks to see if they're equal, they're equal. But this you can't do. This is just an error because you can't get value when get value returns an int, which we saw above that it does, because you should use equals equals for two ints. 2 is D. Okay, this is really tough, I gotta tell you. So we'll do 3 more, 28, 29, 30, 28. No, in fact, changed my mind. This is a two-dimensional array question, so that must be what the remaining 12 questions are all about. They're about 2D, so that's a good place for me to stop this video, and you can stop watching. And this is what we're going to pick up on the next class.